Welcome back to the channel, everyone. In this video, I'm going to record myself attempting the 2021 November Physics High-Level Multiple Choice paper. Tradition for me is that every time I get my hands on a new exam series, I will give the multiple choices a genuine try. Some other YouTube users commented on my other videos that it may be better off if I give an analysis of the paper after I look at the questions, after I look at the mock schemes and prepare my explanations. But I think this other approach of me just throwing myself code into a paper and attempting it, explaining my thought process can also be useful. Plus, I don't really have that much time. I want to record myself like doing it real first, and if it is a reasonable attempt, then I will just post the video instead of the analysis. So hopefully it works out, and hopefully my problem-solving techniques will be useful for a student watching this. And I try to finish the exam in 15 minutes maybe, but of course I'll be talking my way through a lot of the wrong answers, like why the wrong answers are wrong. So, well, hopefully this video does not drag on too long. So let's get started. Make it bigger. Question 1, uncertainty calculations. A ball of mass given is moving with a speed given. What is the fractional uncertainty in the momentum of the ball? So to calculate momentum, it's about doing P equals to mv, and when you have quantities that have uncertainty being multiplied together, the fractional uncertainty is given by this equation. The fractional uncertainty of the overall quantity equals to the sum of the fractional uncertainties of the two quantities that are used to perform the calculation. So here 1/50, I hope you guys can recognize quickly that this is 0.02, so 2%. Meanwhile, the speed uncertainty, 1/25 corresponds to 0.04. Therefore, the answer is C, 0.06. Second question, the graph shows the variation of time of velocity of an object. Let me just clear the screen first. What is the variation of the time of the acceleration of the object? If you know your math calculus well, and even SL people should know this, the acceleration time relationship should be the derivative of the velocity time relationship. And of course, the derivative refers to the gradient of the original graph. I think A is the correct answer because at first the graph has steep positive gradient. Eventually, after half the time has passed, the velocity maxes out, and when velocity maxes out, the gradient of the graph becomes 0, and that also corresponds to acceleration equaling to 0. And you know what? I'm just going to go for A. Third question. Connected objects rarely showed up in past paper. I'm glad that it shows up because school usually does not teach it a lot. So I'm glad as a teacher that does not teach at a regular school. I think this kind of question is a highly discriminating question, as in like good students know it and then bad students. Okay, I should say underprepared student. So no student is bad. It's just that they're underprepared. Back to this question itself. Two objects' masses given. They also have a constant horizontal force of 12 newtons. Well, actually, this is the constant horizontal force of 12 newtons acting on y that's shown. Frictionless table, oh, that's interesting. The acceleration of y should be the same as the acceleration of the system. So you have got 12 equals to 4 plus 2 times a, y, which is the same as a system. Therefore, a just equals to 2. The tangent in a string, however, can be figured out two different ways. You can focus on either the tension acting on x, which is a forward tension. You can also focus on the backward tension acting on y. If you decide to use x, then you'll just look at t equals to, well, we're just using F equals to ma on x. So the only force acting on x, well, the only horizontal force acting on x is tension itself. So therefore, T, which is what you're trying to find, would equal to mass of x, which is 2, multiplied by acceleration, which has previously found to be 2. Therefore, it should be 4. And if you decide to use mass y, which is more complicated, but you should get the same answer, you have a forward pull of 12 newtons being partially countered by the backward tension. So the difference should correspond to the resultant force that y experiences. And then not surprisingly, the final answer is still the same. And for F equals MA type question, I find a lot of students being unable to write the proper expression for the F within the FNet. They often think that F is just a single force all by itself, such as a 12 or such as a T. Depending on the choice of the object, you pretty much need to find the so-called vector sum of all the forces. And of course, when we are using the word sum, we don't literally mean that we add them together. And that's like the misunderstanding for a lot of like AISL students, maybe. But in any event, the answer should be A, and I have no doubts about this one. Question 4, a net force Fx on an object of mass m that's initially at rest. So they give you a force distance graph, and what you guys should recognize is that the area under the force distance graph should correspond to the work done by the force. And they ask you for the speed of the object. So you further need to recognize that work done in the situation when the object, I'm guessing, move in a straight line with no slant and no friction. The work done, put it around in quotes because we actually need to look at the area under the graph instead of just doing force times distance. And in a situation where the force is not constant, we have to use the area, or we have to use the average force. And then the work done by this force should result in the gain of kinetic energy, which should also be the same as the final kinetic energy, because the object was at rest at first. Yeah. So half F1s equals to half v squared. Therefore, v should equal to F1s divided by m, with the halves canceling out. Well, that should be a square root like this. So the answer should be B. And I think C will be the trap choice, but hopefully you guys don't fall for it. Question 5, is cyclist rides up a hill of vertical heights given? So mostly a power situation because I see efficiency. The combined mass of the cyclist is 80 and the power developed by the cyclist is that. What we need to do is to look at the gain of GPE of the cyclist. More than the rate of gain of GPE of the cyclist, because that should be the effective power. So they give you the time and they give you the gain in height. Speed is constant, meaning that the kinetic energy is constant. So any work done by the cyclist does not result in a change in KE. There's no mention about friction, weirdly. So I'll just assume that the effective power output is the change in GPE. So AT times gravity, which is 10 times 100 meters, all divided by 500 seconds. Cancel. That's 160. And then P in is 200. So therefore, efficiency equals to P out over pin, and that should be 80%. I don't think I made any mistakes. I'm guessing A would be the trap answer if you ignore gravity. So I'll clear the screen and then put D as my answer. Question 6 looks like some momentum problem, because when you shoot a pellet into a block and the systems move together, well, let's see, block resting on a frictionless horizontal surface. An air rifle pellet is fired horizontally into the block and remains embedded. So this is analogous to an inelastic collision. The total kinetic energy of an inelastic collision will decrease for sure, but then the total momentum should remain unchanged. So therefore, the answer should be C. And is there a simple explanation why total kinetic energy has to decrease? Well, it turns out you just need to do some like analysis. So what kind of analysis? Probably not something that you'll do on the exam. And this, by the way, is the notes that I use to teach my students. And this is not a derivation that you will be expected to do on the exam, but what I tell them is that a perfectly inelastic collision corresponds to two objects being joined. The conservation of momentum equation, well, conservation of momentum is still obeyed, and then an analysis of kinetic energy. So basically, you calculate the starting and final kinetic energy in terms of V, and then you can see that there will be a difference in kinetic energy by the end. But for now, we'll just move on. Question D. Well, that's interesting. A ball rolls on the floor towards the wall and rebounds with the same speed. So this is like a bird's eye view. And the direction of impulse applied to the wall by the ball. So it appears that the horizontal speeds have, well, horizontal velocity has changed, but that the vertical speed has, well, the up-down speed has not changed. So I'm pretty sure the impulse should just be B. And I'll just draw the final, I'll just draw the vector diagram. If this is the V initial, and this is the final velocity, so therefore this has to be the change. All right, moving on, question 8. A liquid is vaporized into become a gas at constant temperature. What quantities are greater for the gas compared to the liquid? Liquid should have higher. Definitely not root mean square of speed of the molecules, because constant temperature means like constant average speed, and root mean square speed is just a fancy way of saying average speed. So I'm pretty sure B is correct, but then total intermolecular potential energy has everything to do with molecular separation. And the average distance between the molecules, for sure, gas molecules are more spaced out. More spaced out, so a weaker intermolecular force of attraction. And weaker attraction means higher potential energy. Question 9, an insulated container of negligible mass contain a mass of 2 m of a liquid, and you put metal in that. Oh, interesting. So this is a ratio problem. I think this is like the first ratio problem within the entire paper. So we look at the heat energy gained by the cold object. And we're going to equate that, because I think the metal is hot, E equals to MC delta T liquid. So we look at M and the C metal, because we clearly need to denote the two C's differently, because we are trying to figure out the ratio of the two C values. T metal is 80, and we can just use the absolute value. E equals to 2M and then C liquid. And then the delta T for the liquid is just 10. And if we just cancel all the M's, and then divide and then do some cross division, then we have 80 over 20 equals to C liquid over C metal. And the answer is clearly B. Question 10 is a PV equals to nRT situation. The molar mass of an ideal gas is M, a fixed mass of the gas is expanded at constant pressure, and then the VT graph is shown. This should be a simple application of PV equals to nRT. And then you further replace N with mass over molar mass, so chemistry student probably would have an easy time. Because capital M is, I'll just write MR. And then the gradient, well, let's just make V the subject first, because V is clearly the y-axis quantity. So the gradient should simply be small m times capital R divided by pressure times MR, and that looks like, and D looks like the correct answer. So the notation is a little bit confusing, but overall it's not a difficult question. Okay, question 11. Traveling wave on the surface of a lake has a wavelength lambda. 2 points along the wave oscillate with a phase difference of pi. Phase difference of pi should mean that they are out of phase. And if they're out of phase, they simply have half a wavelength of path difference. And is there an explanation for it? Well, it's just how people translate wavelength, path difference, and phase difference. So a wavelength of lambda correspond to a phase difference of 2 pi. And the phase difference and number of wavelengths is directly proportional to each other. So this would be phase difference of pi and also lambda over 2. Question 12, polarization. Interesting. Horizontally polarized light, so the light's already polarized. The axis of polarization of X makes an angle of theta with the horizontal. The axis of polarization is vertical, so it's just going to be 45 degrees. Why is it 45 degrees? Has to do with some trick. I guess intuition also says that should just be 45 degrees. 0 and 90 will cause, well, 0 degrees causes Y to block everything, whereas 90 degrees will cause X to block everything. 180 is the same as 0. But if this is a paper 2 question with no choices, then I'll just show you not this, because this is my biology notes. And the best angle is basically 45 degrees, and that's because of this relationship, I equals to, well, I transmitted equals to a quarter times I naught sine squared to theta. And of course, sine squared is maximum when the content of the sine is 90. So theta has to be 45. All right, moving on. Need to minimize my biology notes. Question 13. Diagram shows an interference pattern observed on the screen in a double slit experiment. I think this should be a simple application of the double slit equation, which reads what? Well, S equals a lambda d over d. Capital D is the screen slit separation. Small d is something that you are trying to find. 1 cm contains, I'm guessing there will be 10 fringes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, small s is 0. It's 1 mm, so it's 0. I'll just use standard form. 1 times 10 to the negative 4. Is it? No, I'm trolling. It's 1 mm, so 10 to the negative 3. Wavelength is 6 times 10 to the negative 7. Capital D is 1. Small d is to be found. And if we just rearrange, I think small d is just 10 to the 6 times 10 to the negative 4. So hopefully I did not make a mistake there. But there's nothing fancy about the theory of this question. Okay, question 14. What is this? A string fixed at both ends. So this is a standing wave question. The first harmonic standing wave for a fixed double fixed string should look like this. So the waveform will just go from forming a half of a positive sine graph to become half of a negative sine graph over half a period. So P should be an antinode, but Q should not be a node. Should be just D, right? All points oscillate with the same frequency. Okay, and antinode has the maximum amplitude. Q would have some decreased amplitude, maybe like 1/√2 as much amplitude. Question 15 is electrostatics. Let me clear the screen first. Magnitude of the electric field potential at P alone is E. Oh, interesting. So there will be some vectors involved. So what's the total electric field at P? So E, the Q is K Q over X squared, which is given to be E. And this is to the right. Meanwhile, the electric field produced by the negative 2Q is K bracket 2Q. So ignore the negative sign for now, because we'll just interpret that the field is also pointing towards the right. The distance is 2x all squared. So I think this is overall 2kq over 4x squared, and this should amount to 2 over 4 E of the field produced by the first charge. And because they are cooperating, you will actually find but the vector sum is literally the sum as well. So it should be 3/2, and to the right should be correct. Uh, 16 2 wires, so this is resistivity, I'm guessing. Same with, wait, let me write. So the equation for resistance is R equals to rho L over A. I think the formula book has rho equals to R A over L, but then when I teach my IGCSE students, we usually use this version. I think this is the better version because it shows R depends on the material property as well as dimensions of the conductor or resistor. So we'll just use fraction Rx over Ry equals to rho XL x over AX all over rho YLY over AY. Equal length and equal material. X has twice the diameter, so classic trap. So if the diameter is twice, I'll just finish writing this first. Rx over Ry equals to AY over AX. So if the diameter of X is twice that of Y, then the cross-section area of X is 4 times. So the answer should be A. Question 17, a cell has an EMF of that and internal resistance of that. The cell is connected in series with an external resistance of that. So it should be a simple series application. So you just need to draw a resistance in here. And terminal potential difference would be the potential difference measured by a voltmeter like this. Because you can't physically insert a connection between the battery. You can't really isolate the internal resistance from the source voltage itself. So we can just use ratios. Our answer should be 2.5 because so reading would equal to 3 times, or 3 divided by 12 times 10, or we can just use ratio like this. Either way should be 2.5. Moving on, question 18, 2 parallel wires carry equal electric currents in the same direction. Out of the paper, so this is a right-hand straight wire grip rule situation. And what you want to do is to have your wire pointing out of the page. I'm pointing towards myself. And then what you want to do is to grip grip the straight wire with your right hand so that your thumb is lined up with the direction of the current. I think A looks promising because when you have 2 anti-clockwise oriented field lines, the field in between the 2 wires should cancel because the field lines are acting. One field, because the left wire produces an upward directed field and then the right wire produces the field the other way. So I think C and D would just be wrong. Question 19, interesting. A mass at the end of a string is moving in the horizontal circle. The string makes an angle with that. What's the magnitude of the acceleration of the mass? And should be sine. But let me just do the free body diagram first. So you have diagonal tension. That's theta. That's T. This is T cos theta, which cancels with the mg, whereas T sine theta, well, actually it's not sine. Had it had T sine theta, then sine theta should be correct, but I think it should be tangent. But let me finish the derivation first. You're looking at T sine theta equals to MA or MV squared over R. But if we just divide the 2 equations with each other, sine over cos is tangent. I hope most people know that. Tangents cancel. So tangent theta equals to A over G. So A equals to G tangent theta. So 19 is D. And these diagrams are something that's often poorly understood by students. And none of these diagrams are, some of these diagrams are in textbook, but none of these equation derivations are presented in the formula book. And I'll just show you my own versions. Yeah, topic 6 is not a very long topic, but most of the analyses, most of the force applications, like people are just ill prepared for them. There's so many different kind of geometries and different situations, and you have to know how to draw force diagrams to describe like the individual components which may serve as a centripetal force or which may balance out some other components. So cone pendulum shows up a lot. And another common question about this setup is that they will ask you for the rotation velocity of the object. So make sure that you guys know how to derive all these equations. Again, none of these are actually given, so it's super important. Let's go back to the test paper for now. Question 20, a detector measures the count rate from a sample of radioactive nuclide. Nuclide has a half-life of that, and the average background count rate is constant. Interesting. And they ask you for the average background count rate. So half-life of 20 means that after 20 seconds. Wait, what is this graph? This graph shows a variation with time of the count rate. Wait, so after 20 seconds, the count rate has gone from 19 to 11. So the sample count has decreased by 8, which means that the original sample count has to be 16, which means that the background count has to be 19 minus 16. So that's difficult. Well, 21, the mass of a nucleus is that, and what is the mass defect of iron 56? So the mass defect has to do with the sum of the masses of the individual protons and neutrons minus the observed mass, because the observed mass is always smaller than the sum of the individual masses. Like as the mass loss results in binding energy released. The answer to this question should be, I think should be B, because the question says that it's the mass of the nucleus, so which means that we should not include the electrons. Haven't seen this kind of question in some time, but I think we do have this brought up somewhere in our notes. So be aware of the need to include the electrons. So the mass defect, which is equal to the sum of the mass of the nuclear content. We'll just move on. Because the mass that is given is the nuclear mass and not the atomic mass, unlike the other work example that I have. So I just choose B. Hope it's correct. 22, Feynman diagram showing how a proton interacts with an electron. Charge of the exchange particle is basically the same as Kirchhoff's law. So a proton is +1 and the neutron is neutral. Therefore, this has to be a W minus. Lepton number of particle X. The exchange particle itself has no lepton number. And meanwhile, the electron has a lepton number of +1. Therefore, the particle X should also have a lepton number of +1. If they show you this question in this paper as a paper 2, then you have to recognize that this is an electron neutrino, and this process is actually called electron capture. So the answer should be B. 23 looks like some nature of science stuff. Higgs boson. Which statements are correct about the discovery of the Higgs boson? It was consistent with the standard model of physics. I think the Higgs boson was postulated to exist, so I don't think it's independent of previous theoretical work. And I think the standard model predicted the existence of Higgs boson. I'm guessing 2 is correct, so I'll just go for C. Hopefully it's correct. I won't think too much about it. 24, a field has mass density that and energy density that. What mass of the field has to be burned to release thermal energy E? That's confusing. This is because energy density is known to be joules per volume, and then density is kg per volume, mass over volume. And you just need to remember your definitions. I think the J per kg definition is specific energy. So what mass of field has to be burned in order to release thermal energy E? So if 1 meter cube provides J1 U, then to release thermal energy E, we need E divided by U. And this is meters cube. And to convert this into a gram, we need to do E divided by U times density. So I'm guessing it's A. When in doubt, you can also use unit analysis. So is choice A consistent? It's a unit of A, so kg per meters cube times joule divided by, the U was joules per meters cube. So I think the unit is indeed consistent. So unless I mess up with my definition, I'll just go for A. Question 25. Diagram shows some simple model of the energy balance. What's the average intensity radiated by the atmosphere towards the surface? It should be a simple energy conservation exercise. So I don't think anything that happens with the incoming radiation is unaccounted for. If there's that much surface radiation reaching the atmosphere and then 240 out of 390 leaves, then I think the remaining 150 would be coming back. So I hope the answer is just B. 26, a simple pendulum undergoes simple harmonic motion. GPE is 0 at the equilibrium position. How many times during one oscillation is the kinetic energy of the pendulum equal to this GPE? So what is one oscillation? So one oscillation can be like this. And there should be 1 point, 2 point, 3 points, 4 points during one cycle, where the two energies have to be constant, have to be equal to each other. So answer should just be D. Interesting question though, never seen this before. Monochromatic light is incident on a single slit. A diffraction pattern forms on a screen, and now you decrease the width of the slit. So the single slit equation is angle equals to lambda over B, and B is the width of the aperture. What are the changes in the width and the intensity of the central maximum if you make B smaller? Well, if B becomes smaller without changing the wavelength, then the angle becomes wider. So the width should increase, but then the overall intensity should decrease because there's simply less light being emitted through. So the answer should be B. Okay, question 28 is thin film. That's interesting. Air, film, and air. So you have to recognize that there will be a phase change here. When light travels from air and hits a film, and the film in general having higher optical density than air. So no phase change when light travels in film and hit air, which is a less dense boundary. And this has everything to do with the wave reflection properties. So basically we need the wavelength within the film, but the length of the path within the film to correspond to a full wavelength So the full wavelength in the film needs to equal to, wait, are they looking for, oh, they're looking for constructed indifference, then we need the path length in the film to correspond to an integer plus half multiple of the wavelength. Wait, where's the thickness of the film? The thickness of the film. The thickness of the film needs to correspond to a half the wavelength, actually 2t, because the total path difference is this, half film. And of course, you have to give your answer in terms of the original wavelength. The original lambda divided by the refractive index equals to the lambda within the film. Therefore, T should equal to lambda over 4n. That's confusing. Hasn't come up in a long time. And I have not been practicing clearly, and that's why I struggled a little bit. But I think the answer, I hope the explanation is still correct, and hopefully the mark scheme will be in my favor. 29, a beam of light containing two different wavelengths is incident on the diffraction grating. The wavelengths are just resolved in the third order of diffraction. How can you increase the resolution of the image? The resolvence equation is lambda over delta lambda equals to n m, where m is the order, and this is the number of slits illuminated. You can actually make the beam wider, and this can make this bigger, which means that you can resolve a smaller wavelength difference. If you decrease the order, you make the fraction on the left-hand side smaller. If you decrease the number of lines per unit length, then you're using the same beam width to illuminate fewer slits. And intensity, I don't think has anything to do with this, so I'll just choose A. Question 30 is about electric field. Which arrow represents the acceleration? Well, the electric field line should be perpendicular to the electrical potential lines, which I'm guessing it should be either B or D. And then they want an electron, which is negatively charged, and the electron should accelerate towards higher potential. Therefore, the answer should be clearly D. 31, they give you a potential difference between two parallel plates. A particle with charge plus 2 mu c is moved from here to here. When the positive charge moves from low potential to high potential, it gains EPE. And the difference is 10, so 10 times 2 is 20. So it gains, the change in electrical potential energy should be positive and should be 20. So answer should be D. Okay, satellite thingy, clear this. Satellite of mass M orbits a planet of mass in a circular orbit of radius R. And this question is not asking for the height of the orbit, but they're actually talking about the radius of the orbit. So they go from R to R, but then the total orbit energy of a satellite, as opposed to the object being stationary, the E total of an orbiting object is the same as the negative of the KE. Just in general is this EK plus EP equals to half GM M over R minus GM M over R equals to negative 1/2 GM M over R. So the work that must be done on the satellite to increase its orbit to 2R should be a simple difference. So the difference in energy would be the final energy should be less negative because the satellite is further away. Is negative half GM M over 2R minus minus, so plus half GM M over R. And I think it should just be choice C with the denominator of 4, because minus a quarter plus half gives you positive quarter. 33, electromagnetic induction. The variation with time of the EMF induced in the ring should be C, because there should be an entrance point and then a leaving point. And I'll just go for C and I'll show you my notes. Could I have used my notes for the question? I could have, I guess, but I don't want to cheat. I would say out the answer that I have in mind before I show you the notes. So what the question presents is basically a shorter version of the long pipe. So with the long pipe, so this is like with the magnet spending more time in the interior of the long pipe, there will be some duration where there's no EMF. But if the pipe is replaced by a ring with negligible length, then there should be a very sudden increase and then a decrease. Well, more like an increase in EMF on one side, and then the EMF quickly decreases to zero, and then they develop, and then it becomes like in the EMF in the opposite direction, all because of Lenz's law. 34, bridge rectifier. The conventional in the load current, so easy way to deal with this is just to assume the top half is positive, so it will be from Q to P. And I'm going to reverse the direction of current by setting the bottom to be positive instead. And you can see that either way, the current is from Q to P. So D is wrong. Unfortunately, we don't see the correct answer immediately. The conventional current in the load resistor should be a maximum twice during one oscillation of the input voltage. Looks correct. Because with the unrectified voltage, just this, and the rectifier will cause a negative voltage. But regardless of the direction of voltage, the current will always be like this. So you have two maxima during one oscillation. So the answer should be A, and then I'll show you my notes. So the rectifier will give this sort of current. But with the capacitor, I think it will be even smoothened. So full wave rectification without smoothing would be the red dotted line, with smoothing, blue line. All right, let's go back. 35, the root mean square current in the primary coil of an ideal transformer is not. The root mean square voltage in the secondary coil is not. Average power, oh, this is annoying. So this is primary current. They give you RMS voltage in the secondary, and then the average power also in the secondary. So P average equals to IRMS VRMS. So therefore, the IRMS is, so IRMS equals to 0.4. And then in the if the primary current is 2 and the secondary current is 0.4, so the current has decreased by a factor of 5, which means that the voltage would have to increase by a factor of 5, which means that the turns ratio is also going to increase by a factor of 5. So N, they give you NP over net, that's annoying. So I secondary over I, I'll just use 2 and 1, I think it's clearer. And they're not really giving you maximum quantities. So every single quantity is given as either RMS or average, so that's good. So the current ratio is 0.4 to 2 equals to 1/5, which means that N1/N2, because number of coils is inversely proportional to current in the transformer. So it should be this. Power for a transformer is supposed to remain constant. So therefore, the answer should be C. That's very confusing. Capacitance. So a capacitance in series, the charges are the same, and if Q equals to CV and charges are the same, then Vx, so the V should be inversely proportional to the capacitances. So Vx over Vy should be 2 to 1. Therefore, it's just 2. 37 in the photoelectric experiment, a stopping voltage V required to prevent photoelectrons from flowing across the photoelectric cells measured for 2 light frequencies, and the results are obtained. Well, that's confusing. So this V2 over V1 minus all over F2 minus F1 should just be the gradient of this section. So what should be the equation of this straight line, you guys wonder? Well, the equation, so the K of the photoelectrons equals to the incoming photon energy minus the work function. The incoming kinetic energy can be dissipated to become potential energy by using a stopping voltage. And the graph plots capital V alone, which is a stopping voltage, so you can just divide both sides by the elementary charge. So the gradient is D. Question 38. So this is uncertainty principle, and I got this question wrong in the previous paper, 2021. The component of momentum of the electron in the y direction after passing through the slit is P. The uncertainty, so the position, uncertainty equation is this. And a lot of times the inequality sign is used as an approximately equal to. So the momentum of the electron in the y direction and the slit, the width is also in the same direction, so it should not be 0. I think the answer should just be this, because delta x is basically uncertainty in D. Well, uncertainty in D is uncertainty in X. And this is an inverse proportion situation. So hopefully I get this one correct this time. Okay, nuclear energy levels. Some of the nuclear energy level of oxygen 14 and nitrogen 14 are shown. Nucleus of 14O decays. So these are the possible decay energies. What is the maximum energy of the positron and the energy of the gamma ray? Oh, this is actually a beta decay. It's possible that you release O4.1. Wait, do they say that the decay, a nucleus decays into a nitrogen 14 nucleus with the emission of positron or gamma ray? Well, the gamma ray will be emitted as this. And it's possible that the positron takes all the decay energy, because this decay energy of 4.1 MeV has to be shared by the positron, the daughter nuclei, and also the neutrino. But with 3 particles sharing energy while obeying conservation of only 2 quantities, namely kinetic energy and momentum, the 3 particles can share energy in many different ways to allow like conservation of momentum to also be obeyed. I think the answer should just be D. It's of course, it's also possible for the oxygen to decay to the. But did they mention about the decay to only the excited state? Wait, I might want to change my answer. If the decay occurs all the way to the ground state, then of course there won't be any gamma ray photons emitted. For the gamma ray of 2.3 MeV to be emitted, you need the oxygen to decay to the excited state. But whether the decay goes to the excited state or the ground state are separate events. But if they say that the single nucleus decays, and the decay is accompanied by the emission of both the positron and the gamma ray, then I'm guessing it should be A and Z, because the 1.8 MeV of energy difference is the energy that has to be shared between the three particles that have mass, while the gamma ray energy would just be the 2.3. Well, that's confusing, but hopefully now it's correct. Lastly, the size of the nucleus can be estimated from electron diffraction experiments. What's the order of the magnitude of the Broglie wavelength of electrons in these experiments? This is annoying. The size of the nucleus is 10 to the negative 15-ish. I said 15, but I wrote 5 for some reason. And you need a wavelength to have a similar order of magnitude to the nuclear radius in order for them to interact. And finally, this is the equation. It's not given in the formula book anymore, but it's easy to just remember HMV. So here you're looking at, so 10 to the negative 15. Wait, no. Well, I don't think you even need to use the Broglie equation to calculate the momentum of the photon. I'm guessing if the answer is just A, 10 to the negative 15. And I don't think there's anything else. But if you want to look at atomic, if you want to do X-ray crystallography, then you need to use electron wavelengths that are more comparable to the size of the atoms. But if you want to probe the nuclear structure, then you need even higher energy experiment to get to the shorter wavelength. Well, I guess that's it. So I'm not going to bother checking the answer. Rather, I'll just jump into the mark scheme and accept my fates. Let's go. So CAABD, this is all good. CDBBD is all good. BBDDC all good. ACADC all good. BBCAB all good. DBAD looking promising. DCCAC, CDBA. Oh, that's actually a clean victory. All 40 questions correct. All right. Yeah, it's pretty satisfying. But hopefully you guys also understood even some of the questions that I'm not too certain about. I think overall my explanation is still sound. And yeah, I guess that's it for us. But that's it for us for science anyways. And I still want to do the math HL paper sometime down the road. But if nothing else, then I guess we'll just see each other in a different video. Thank you for watching.